Show you how the trace for this works. So we've got our program up here. So in English it's doing load counter into the accumulator, add 15, store the value from the accumulator back to the total. And we've got two memory locations where counter is and where total is. They're in different places. But the thing to remember is that the program instructions are in consecutive locations. The machine wouldn't work, the fetch execute cycle wouldn't work without that in place. So when we start off, the program counter will contain the address of the next instruction to fetch, so that's A, B, C, D. So the steps of the fetch execute cycle. So PC gets copied into the MAR, okay, so that's the address. The next step is that the address here is used to access memory and at this address. So we go to that address, A, B, C, D, which is this one here. Okay, this one here I'm highlighting, and then it will fetch the instruction or the whatever data's in there and put it in. So it's going to put into here this instruction, and this is in assembly language, okay, but it's just a notation for representing the instruction. It would be in binary. So as soon as that happens, the program counter needs to be incremented, because its definition won't be true otherwise, because its definition says hold the address of the next instruction to fetch, and we've just fetched one. Okay, so now in our trace table we have to start writing on this line. We must, anything else we write now will be on this line until there's no space to write anything. So I've incremented that, and the next step is then to copy what's in the MBR into the CIR. So let's do that. So that copies it into there. Now that's the fetch done. So what we need to do now is to execute it. So the control unit will look at this instruction and decide what to do. So it says load the register R0 with the contents of DCAF, and DCAF should be the value 45. So in order to do this, it's got to access memory again. Okay, so the MAR needs to be given the memory address, and then we can fetch into the MBR whatever's in that address. So that will be 45. I put a hash to distinguish it from an address. It's the number 45. Okay, so we've done that. Now the next thing it needs to do, we've got to carry out the instruction, and the instruction says copy that into R0. So into there I'm going to put the value 45. So I've just fetched, decoded and executed. Now I do the same again. We go through the cycle. So the PC says it's got ABCE in it, so I've got to copy that into here. So there's no room in the MAR, so I need to write it underneath. So the ABCE, so then I access memory at that location and fetch the instruction. So that's a different instruction. The program, the control unit wouldn't understand it yet. It's just data. So as soon as I've brought that in, I need to increment the program counter. Okay, so I increment the program counter, and it will increment by 1. So that's the fetch. Well, I've got one more thing of the fetch, is copy that into here, 0 and then hash 15. Okay, so now I've got to decode it and execute it. So decode it, so it says to add, so understand I need to add something. What do I need to add? I need to add the value that's in here. Okay, hash 15, we've got to add that to R0. So if I add that to R0, I'll get 60. Okay, so I've fetched, decoded and I've executed. Now I do the next step. So the next step is to take the program counter and copy it into here. Okay, so I'll copy it into here. Now I access memory at that location and fetch it. So it's str R0. So I'm going to store something from R0 into the memory location FAC7. Because I fetched it, I need to increment. So that'll be D0. Okay, I'm adding its hex, so that'll be D0. So I've done the fetch, except the last bit. So let's R0 and then FAC7. So there's the fetch done. Now I need to decode that and execute it. So if I decode that, so it says store R0 into FAC7. So FAC7 has got nothing in it and it's total. So I have now got to access that memory location and put something in it. So I've got to copy the address into here. I've got to copy the data, so whatever's in R0 I need to put into here, 60. Now I can do the store, because I've got the two values. I know where I'm going and I know what value I'm using. So into total I will put 60. Okay, so when we are tracing through, this gives you a good idea of what's going on. Okay, at the end of the fetch execute cycle, the bit I'm including on the trace table is the status register. Okay, so we'd always be at the end of each cycle, we'd be checking the status register, can we carry on?